Hey guys, welcome to the lab. Today is a blast from the past. I have here an old clothing dryer I picked up on Craigslist for, I believe, $20. And I rewired it so that instead of a 220 or 240 volt input, it has a 115, 120, whatever you want to call it. That's actually pretty easy to do. It is a series circuit. I can't guarantee all of them are like that. This is a Whirlpool. I don't know when it's from, early mid-2000s probably, something like that. My first problem is that this diddly-do here came off when I was moving it. I cracked it right off, which is fine. I'm gonna need more than 70 minutes anyway. I'm gonna need this to basically be on for days potentially, because this is going to be a ball mill. I finally broke down and ordered the balls. Let's see if I can find them. Son of a... These are supposedly unused, refurbished alum ceramic aggregate. They look like marshmallows, but I assure you they are not. They sound sort of like marbles or something, or what is that? Those little balls that spark together sound kind of like that. Anyway, this stuff was about $50 including shipping for 20 pounds, and that is about the cheapest aggregate I could find. Aggregate slash substrate. Short of lead. I didn't want lead because not only will it just kind of be messy, it's also kind of soft. And the worst part is it will dope my end results, and I don't want that to mess with my findings when I'm doing some research on various carbon structures and that sort of thing. So the thing about this is all it does is spin a chamber. Now I had done a quick experiment using a tie down and some rope. I had this done years ago. I don't know how long you've been subscribed or watching my stuff, but I have a ton of projects that are basically my wife bothers me to finish. I finished so few of them, and I have so many started. Geez, in programming projects back in the day, I actually had, even before I started consulting professionally, I had over 2,000 projects started in a single folder. I got a wacky mind. It compels me to do things. Anyway, so I'm gonna have to remove that, which is no big deal. It's just a mechanical switch. I'll just short the leads and it'll be fine. It still has this switch right here. I can't recall if that does more than one thing. I'll find out. It's a little bit dirty. The second part of this project is I need to get some wood bracing in here or something to hold a 5-gallon bucket. I would like to be able to insert and remove the 5-gallon bucket so that I can, more handily deal with the situation essentially. So what is this exactly? What is this timer mechanism? Well, you can set it. It has a one-way clutch, most likely. I haven't really operated it in forever. And this right here you see is a 60 hertz timer. So if your hertz on your line is different, then your timing is different actually, which is kind of funny to think about. I'm sitting here, why isn't this working? Why isn't this working? Hot wiring, all this crap. Trying to figure out why isn't it working? And finally I take off the light bulb, simplify, and and that's when I realize there's a door sensor. And then I check, sure enough, this wasn't closed all the way. Then I close it, bam, starts right up. Well, that just figures. I was really just thinking, this can't be that hard. How can I show other people how to do this if I can't even figure it out? And I know a fair amount about electrical circuitry. But yeah, it's simply because the door wasn't closed. Wah wah. Alright, so I'm going to look at what I'm clamping here and short some wires. So what's going on here? Well, to be honest, I'm not even entirely sure myself. These are the things that are shorted together. These are things that are separated. These are things that are separated, and these are things that are separated. Now, half of this stuff I had already done years ago, so I really don't remember much about it. I can tell you there was a heating element and there was a manifold between here and here. I remember that much. I actually took off the turbine blades here because they would have just moved a bunch of air around, disrupting things that, you know, they had no value to me anymore. So this still spins. I believe it is tied to the AC motor. So this is probably directly on the axle, actually. In fact, I bet it, and when I rotate that, it moves the whole chamber. All right, so half of this circuitry is dead. I can tell you the heavy gauges of wire are to the heating element. The heating element sucks a lot of juice. The AC motor, not so much. How did I figure out how to wire this stuff at all? Well, if you look at this, you can see that, let's see, these two things here that are connecting, those obviously are something that gets shorted. So I tied this white and brown together because I could see those get shorted. You can pretty much tell by the contactors what's going on. Here you can see another thing, and look at that. It looks to be designed to push all the way up. So I looked at this and I saw all these wires here. So I knew to short these together, and I knew to short this heavier one together because it's right here in the center. And what was here? Well, that was a red, another heavy gauge wire. I really didn't take the entire wiring apart, but what I did was I just looked at the contactors. And that's how I determined what I should short together. This is the most important part if you're modifying one of these. Right here you can see your 3 wires. So what are they? This white is your common, and then these 2 are your hots. One is red, one is black. And normally what you would only see your common and your hot, and your hot's going to be all you worry about with you know, most 120 appliances. And then right here, that's what gives it another 120. And you put those together, and if you do that in series, that becomes your 240. So I knew that one of these circuits by the wiring was the heating element, so I simply disconnected it. That's it. That simple. For all the safety police out there, basically, was this dangerous? Meh, sorta, not really. The thing about it is, you know, I have this thing plugged in. This is a GFCI line. It's at 20 amps. There's a switch right there. Put a power strip in. It has its own fuse. There's also GFCI. You know, you can flip a switch back and forth really easily and quickly in case something goes wrong. Usually even save like a shorted coil or something if it's actually a short. What is the danger? If I'm touching this with my body, sorta, but there's GFCI. So there really isn't that much danger. It seems kind of dangerous when you're just tinkering around, but it's really not that dangerous. The worst that can happen is a short, it trips your circuit breaker. It's not the end of the world. So that's kind of my philosophy when I'm doing anything questionable with electronics like this, using the mains. Could I be safer? Sure, rubber gloves, rubber boots, or I could have actually gone online and maybe ordered the actual service manual or something, but I didn't want to deal with it, and this was pretty rudimentary. Everything about this is just mechanical and electrical. I measured the interior of this, roughly guesstimating the diameter of this as being 12 inches, so the displacement I just kind of roughed. And with that displacement in mind, I cut some 2-foot boards, which I fully expect to have to trim. I'm just going to kind of do a loose fitting and figure out if they'll actually fit in there. Well, that last 1/4 inch does it. So I'm going to basically do some perpendicular sides to this and top and bottom. And it's still a little bit tight, but I think it's tight in just the right way to hold it in place and rotate with the chamber, so I think it's fine. Well, it's not perfect and it's not pretty, but I think it'll do the job. And really, it might even help things move along by having that kind of bump in the cycling. So what do we have here? This is colloquially what is known as charcoal, of course. It is pyrolyzed wood. So essentially what I did was It had some oak burning, and I threw a bunch of ashes over it, and the next day I found this pile of charcoal, and I realized, oh, that's roughly how they make charcoal. I made charcoal. So, what is the deal with charcoal? Essentially what happens is the hydrocarbon gases are released from the polymers of the wood. And what you're left with are complex carbon structures, complex nanostructures with high surface area. This is not to the extent of activated charcoal, which has even more surface area. But it's still useful for my purposes. My objective is to use it as something that will absorb heat energy, or in this case, probably microwave energy is what I'll end up using it for. But it also makes a pretty good resistor because it is so impure. So we want something that's not quite right, you know, electrically speaking, a poor conductor. Let's actually take a look at this with the meter. Yep, there you can see about, call it 138K within the distance of these two probes, which is, I would approximate 3 millimeters of distance. So this is electrically conductive, and that's kind of what's so cool about it. Whoops. Oh, 1.2 M. Yeah, pretty neat. So yeah, this is basically a good resistor. What can you do with a good resistor? I'm going to have a little bit of fun with this. I wasn't expecting to do this in this video, but I've always kind of wanted to try it. So this probably looks pretty dangerous, but yeah, it's only a little bit dangerous. Because we know Ohm's law. So, let me find a good distance here to demonstrate. Yeah, heck, even between there, it shouldn't be much. So I'm going to start out pretty far apart on these probes. So of course this is at 115, or really I believe my line tends to be more like 120 volts. And this distance between here is probably 1.5 to 3 mega ohm. So what I'm going to do is turn it on. Let's add some power and see what happens. Oh, I should have brought my thermal imager. Woo! I would bet right down in the middle it's really warm. I'm trying to figure out why that arcing happened. Let me try this again. The arcing doesn't make a ton of sense to me, unless there are some paths inside of it. I mean, this is admittedly a structure that's, I wouldn't say random, but it's ordered in such a way that you could almost call it random. Nothing much happening so far. Let me cut the power. Let's see. Yeah, that's more like what I was expecting. A whole lot of nothing. Because the resistance between these points is so high. If we bring them closer together. I pre-apologize to everybody who thinks I'm a maniac for doing this, tying this directly to the mains. It's not that big a deal, though. Woo! There we go. Yeah, so apparently between these 2 points, there isn't that much resistance. So there must be a channel of nice high conductor between these 2 points for whatever reason. Let me check what the meter says. Oh yeah. Oh, darn, it just broke. Didn't get a good read on it, but I want to say that was actually closer to about around 100 ohms or so, which does explain it a little bit better. Because that was probably pulling 1.5, 2 amps for a moment there. It's because if you look at this grain structure, it's flowing this way. So what you have are polymer chains that go between these 2 points. So the resistance between it perpendicular to the grain is going to be higher than parallel to the grain. And as you can see, it flakes apart when you're working with it perpendicular to the grain. So anyway, now that we've had a little bit of fun with some dangerous stuff, you get the idea. You can do a lot of stuff with it. The issue is you have to normalize the structure, because otherwise you have what we just saw, which would be channels of less predictable resistance between points. So what we'll do is we'll normalize it by powderizing it using the ball mill. And it has the added bonus of removing the awful smell coming out of this thing. I washed it with soap, I blew it out with the air compressor, I wiped it down with dry paper towel, and it still reeks. I guess that's what happens when you leave 3 years of rotting eggshells in there. I was trying to powderize calcium carbonate from eggshells using rocks from my driveway. Needless to say, I eventually broke down and bought some actual aggregate. The vessel should actually be half full. This is 6 gallons. I would need probably 2.5 times this amount of aggregate, technically speaking, to be using this, but this is really just a proof of concept. All loaded up. Probably the worst thing that could happen, other than just being noisy as heck, which is not a big deal, I'll just walk out of here. It's no big deal. Would be if this top came off and then all the crap scattered within the vessel. In fact, I should probably put a bungee cord across this to make sure that doesn't happen. Probably the biggest issue is that this is going to be moving faster than I really want it to. Let's see what happens. Well, the only problem is that this wants to kind of slide out. I was hoping just the friction would be enough to hold it, but clearly it's not. So, I suppose what I should do is use another one of these to just wrap around here. That seems stable. I'm gonna go ahead and just let this run. It's been about 45 minutes. I didn't feel like waiting longer. Wanted to see how this is going. Wow, this is far more effective than I thought it would be. This has only been, 45 minutes, and look at how much powder that has in there. It's really been beating it up really well. Nice. Yeah. I like that. So it looks like this actually works really well. Probably have to find a way to clean these. I did want to clarify one thing. In case anybody's trying to replicate what I'm doing, I have a disclaimer video that basically says I'm just doing things. It's not necessarily the right way to do things. Take it with a grain of salt. I'm going to say that's also the case with this because there is still energy in this charcoal. There is a reason people use charcoal for high temperature heating of things. This is not an ideal material. It's still pretty volatile. I'm going to be screwing around with it anyway because I saved it basically, and I think that the nanostructures are still pretty useful. But I'll be doing another video in the future using table sugar and sulfuric acid, but you could also just heat it up with a microwave or something like that. That is a more ideal substance. What I'm getting at here is this stuff I'm going to be using for resistance, and it's not impossible that it might have enough energy left in it, enough hydrocarbon energy, that it could potentially cause an issue. If it heated up to a certain amount, it could cause basically a fire. For my applications, it's not that important. Like, for example, I could prevent that behavior by adding boric acid or borates of some kind. That would act as an excellent fire retardant. And I'll also be having to dope this structure. So in a future video, I'll talk about what I ended up doing after trying a few things. I basically just needed something to start from, and this was just a carbon structure I had laying around. I have 50 pounds of it. So I have so much of it, I just figured it'd be a good starting point. If you're going to replicate this, keep in mind that it could potentially be volatile. That's all I'll say on that. If you guys are interested, check out Robert Murray Smith's channel. The guy's an excellent material scientist. and he has all kinds of interesting stuff. That would be a good starting point if you're really interested in replicating this. I just thought this would be an interesting thing. I created a ball mill out of a dryer, so it turned out pretty well. And unfortunately it took me about 3 years to get around to doing this, but it seems fine at this point. And proof of concept, this seems to work great. So I would guess in about 3 hours this will be highly powderized, and from there I can just filter out the finest particulate for my own applications. I hope you enjoyed that. Feel free to like and subscribe if you're interested in future developments. I will be doing in the future a lot more science-based videos, in particular material science, and other things that are more practical. I mentioned I'll probably be doing some smelting designs in a future video coming up. Anyway, stick around for more stuff in the future. Thanks.